welcome to our newest supporter, Timothy Lofton, and William Oosterbaan from yesterday. Well, welcome to Forecast Lab once again. Blue skies, yet again. So I'll kind of summarize here. In the southwest, clear. In the southeast, hot and muggy. In the northeast, cold. In the northwest, fair and mild. Well, thanks for watching Forecast Lab. Hope you enjoyed the weathercast. No, I'm just kidding. Things do seem pretty stagnant, but we'll try to figure out something to look at here for today. All right, I guess there is something to look at there in Nevada. Very strong northwesterly winds, bringing down some mild air from Oregon. And you can see those very dry dew points, -3 at Tonopah, -7 at Austin. And looks like in the San Joaquin Valley, which is right here, northwest winds, and that's usually a sign of frontal passage, especially when the winds are out of the northwest. And ahead of the front, dry desert air, pretty typical of May, and temperatures finally up over 100 in both Phoenix and Tucson. And I just noticed there appears to be that old front that we saw yesterday. It's pretty much on the higher terrain of West Texas and New Mexico. And I think we're going to see that receding northward sometime tomorrow. And I remember that from what the GFS was showing yesterday. The southeastern U.S., not really hot and humid. In fact, there's been a pretty dramatic cool down, especially up in Atlanta, Asheville, Charlotte. Now, it appears the main Bear Clinic system is offshore. Now, it does look like there may be a front there in Florida, and you'll notice that even though the winds are out of the northwest in this part of Florida here, dew points are still pretty high, 66 to 70, and we don't start drying off until we get in this area. So there's a very small possibility the front could be right in that area. Also notice how there's not a very dramatic cool down in southern Georgia until you get up into Atlanta. So I would also be looking at the possibility that the real front may be up in this area. Why did I not do that? Well, the temperatures are pretty mild in southern Alabama and Mississippi. And also if we look at the thickness chart, we do have a gradient in southern Georgia and some troughing indicated by the GFS there. So that's probably, well, I shouldn't be using red, but yeah, that's probably going to be the cold front right through there. So it appears what's further up north is probably a cold air advection trough. And that's kind of where we got denser cold air and a slope in the frontal surface. Well, the southeastern U.S. looking pretty cool again. In fact, a few 30s showing up there in Pennsylvania, 36 east of Pittsburgh. I'm not sure what town that is, but that's going to be close to that United crash site from 9/11, kind of in that area. 36 there, and they're reporting rain. So it is still liquid. But interesting, if you go to the north, up in Michigan, you get right back up into 60s. So there probably is some evaporational cooling going on. Combination of that cold air coming down from the north and precipitating into that dry air, which has given us evaporational cooling and wet bulbing beneath those cloud layers. And this is how it looks to me in the Pacific Northwest. The coldest air is out over Washington and Oregon there. You can see that high pressure moving in. The Central Plains dominated by this big ridge from Manitoba down to Nebraska. And we've got that return flow coming up from the southeast into the high plains. And I will say that that warm front was pretty problematic, because if you look at the warm sector, see how it's 63, 68 down there in Nebraska. Same thing in Montana. Same thing in Alberta. So I couldn't place a warm front through here or through here. I had to put it all the way up in Manitoba, up at the top of the, way up there at the top of the map. And there I can probably start picking out a temperature difference there. It's pretty slight, but That tells me that we're looking at like cold here, warm there, and that would bring the jet pretty far from south to north. So that's what I'm going to expect to see on the upper level charts. Now here we have another potential situation. We're taking that old cold front that went through Texas and bringing the tail end up into that baroclinic system up in Wyoming and connecting up to that cold front. And anything north of that would be an occlusion. And then our jet support would run something like that between the cold and the warm air. And then it would flow over the top and maybe do something like that. So, yeah, maybe that is actually what's happening. Yeah, this air mass looks pretty homogeneous, so I may go with something like that for our analysis here. Let's look at the vertical consistency starting with the 850 millibar chart. This is going to be up at about 5,000 feet. Now keep in mind that this does intersect the mountains out in the Rockies, but the basic patterns shown here can definitely help us out a lot. And what do we see here? Looks like an 850 millibar front from northern Wyoming towards Oklahoma City. And there's the cold front. Okay, so that's interesting. Okay, so plotting the 850 millibar front on the surface chart, we get this. And we can see the slope upward with height, which is what we expect. It always slopes upwards towards the cold air. Same thing with the cold air mass. And this follows the rule that our frontal systems always stack towards the cold air. Yeah, there's the frontal boundaries up at 500 millibars. Some very cold air over Washington and Oregon. We can see why we're getting a lot of instability in that area. Very strong cold over warm situation. And we go up to 300 millibars. There's our jet there coming into Oregon and Idaho, dividing the very cold air over Washington from the very warm air over the Four Corners area. And that jet does pretty much connect down into Arkansas and Kansas. So that supports the surface front being in this area here. It's always found on the warm side of the jet. So this is going to be all the cold air, and all the warm air is going to be over the southwestern U.S. So we've got consistency. Let's look at our moisture return. This is the 925 millibar dew point. This is up at about 2,500 feet or so above sea level. I think this is a really fantastic product, and you don't find too much 925 millibar data online. Now you got to keep in mind that, especially at 925, you're going to be impacting higher terrain. So this is mostly useful for lower elevations, Texas, Louisiana, places like that. But we can see the moisture kind of heading into northern Mexico there, West Texas. And this helps give you an idea of the moisture depth. You go from that, switch over to 850, so you're going a little bit higher, up to about 5,000 feet, and you're sampling the top of the moist layer. So it does have some depth there in the Corpus Christi, San Antonio area. And we can see that at 850, the leading edge of the better moisture is only up to about the Big Bend and Hill Country area. Let's put it around Del Rio. See, that's right in the green at 850. So we know we're going to have some very deep moisture there at Del Rio. See, that goes all the way up to about 8,000 feet or so. And we can see that the dew points actually increase from 54 at the surface all the way up into the upper 50s and lower 60s. So that's our moisture return right there. It's elevated. That can be a good situation there for elevated storms, especially if you have an upper level disturbance approaching the area, which can remove some of that capping and steepen the lapse rates. Let's go further up into the moisture return. Let's try around Fort Stockton. You can see that the 850 millibar moisture is pretty sparse there. And indeed, we go from 48 to upper 40s, mid 40s, and then it just trails off very rapidly to 30s and 20s. So that's not good moisture at all. And so using these charts, we can kind of visualize the quality of the moisture heading into a target area, and that becomes very important as the lee side troughing gets established there in West Texas and the high plains, and we start to see it advance up towards Midland, Lubbock, and so on. Here's another useful product as we get into May and June. Precipitable water. That's an expression of how much moisture you can release out of a vertical column. If it all came down to the ground and went into a rain gauge, you would have this much in terms of inches. And down in the Texas Gulf Coast, that's going to be 2 inches. You can see that on the scale right there. Anything above 1.5 to 2 is getting into like typical warm season heavy rain. And anything above 2 is going to be getting into flash flood territory if you've got enough of a boundary and training of cells and so on. Up to the north, it is drier, values below 1 inch, and you're not going to get much convection out of that. Out to the west in the Four Corners area in Arizona, that's the continental tropical air mass, and that forms a lot of the dry air that you find west of the dry line. So we may see that on the move here in the next few days. All right, so let's take a look at our forecast. I don't want to run late like we did yesterday. So let's run that forward for tonight. Well, there's the cold air mass coming out of Idaho. And let's see, our warm front, stationary front, is going to be still out there in the mountains of Texas and New Mexico. And there's the high pressure there, slowly modifying and giving us the start of our return flow on the high plains. So moving forward into tomorrow morning, looks like we get some showers going up in that isentropic lift area north of the warm front. The cold front is sinking down to the Four Corners area, and let's see, by evening 2122Z, you can see that the return flow from the Gulf is starting to head northward, starting to come onshore right there around Corpus Christi. And I think we're starting to see the warm front. It's hard to tell where that is, but I'm guessing maybe somewhere right there. And then let's see. Then I think we're looking at fronts somewhat like that. See, that's that cool air mass coming down out of the Great Basin area. And I think the dry line is probably starting to get established. Maybe somewhere in this area. This is the very, very start of the return flow coming into Texas. So I don't know. I think this early we would have to look at the dew points. Yeah, there's no reason we can't do that. Let's check that out. Yeah, that's going to be the dry line right there, all the way out in West Texas. So there you go. There's the dry line, and it does look dry along the length of that dry line. Let's go just east of that low and see if we've got any potential for convection, because this would be our most favorite area for storms. Obviously, the sounding is going to have problems, and looks like that's due to the capping. Got temperatures at 700 millibars of about 12 Celsius. The moisture is not too bad. Looks like low to mid 60s all the way up to about 7,000 feet. The problem is going to be clearing that cap. And it is May, so I'm not going to rule out the cap being broken. And if it does, trying to draw that on there. Let's see. Yeah, that's going to be some decent convective potential, very good cape. So if that cap breaks, I do think we'll have some potential for severe weather. Now, another thing I'm seeing is this layer of high moisture. That may be cutting down our surface heating, so I may want to look at the upper charts and see if we've got a cirrus shield affecting us. So what I might do at this point is go through the different models and see if any of them are trying to break out precip close to that surface low. Well, nothing on the NAM. The ARW WRF, which has more sophisticated physics, you can see tomorrow does break out precip. See, there's 6 p.m., there's 7 p.m. It's got that going around Seymour, Texas, the area southwest of Wichita Falls. And one good little cell there near Eastland. And of course that dies off. That's indicative of some strong capping, but that would be something to watch. The Nissel WRF does have another interesting scenario. Convection forming around Altus, moving down the Red River through Wichita Falls, and kind of a small bow echo all the way down to DFW around 11 p.m. And then develops another little MCS out further up there in Oklahoma. Okay, well, that's an interesting scenario there. And it's got Old Faithful developing too. I don't think I saw that on the previous one. Yeah, that's around the Fort Stockton area, way down south. Probably very intense heating. Okay, so yeah, there's definitely potential in northwest Texas for tomorrow. What other models do we have? I think the high-resolution rapid refresh does run that far out. I don't know how good the fields are that far into the future, but let's see what it's doing. Well, it's got a different scenario. Storms coming out of the southwest. And the ECMWF, let's see what that does. It's got thunderstorms developing around Altus, maybe a little further east towards Lawton. And they kind of dissipate and then this big MCS along the front becomes dominant around midnight, west of Oklahoma City to, I guess, Oklahoma City, and moves rapidly southeast. Now, I am kind of curious how well the European model would handle something like this, but yeah, it's got definitely an MCS heading rapidly southeast. So we shall see. We'll check it out tomorrow. All right, then to look at the storm character, let's just bring up a quick photograph. We'll use the basic NAM. Let me get that centered there, and you can see the photograph has the tail end, well, the top of the storm, down in this quadrant of the photograph. So this is pointing towards a northwesterly flow situation. You can see the storm motion is east-southeast. So the storms are going to be moving kind of in that direction and probably propagating somewhat to the south. We see that there's good inflow. There's ample shear for rotating storms. And being aware of this northwesterly flow situation is important for your positioning because you want to be out ahead of the activity and not on the wrong side of the storms. So I would be looking at maybe positioning along the Red River or the southern tier counties of Oklahoma with the possibility of moving over into Texas as the evening goes on. Of course, I'm not going to be out chasing, and there's those concerns about spreading COVID and that kind of thing. So I'm not too sure what I'm going to do about chasing this year, but hypothetically, if you were out, this is what you would want to do. And there's the SPC forecast that kind of falls right in line. This is for tomorrow. Falls right in line with those models that we saw. We would expect the storms to develop in southwestern Oklahoma, along the Red River, and possibly further down into the 287 corridor, maybe down to Seymour. So those could develop upscale and move towards the Dallas-Fort Worth area. And then that second punch possibly coming in with the forcing along the cold front. And as we saw, the European model pretty aggressive with that. Same with the research, the ARW models. Not so much with the high-resolution rapid refresh, which was kind of keeping that front back and bringing cells out of southwest Texas. So that's how things look for tomorrow. And I'm going to go ahead and get this uploaded, and we will see you tomorrow. We'll cover some of this in depth, and we'll try to get the program out a little early so you can follow what's going on. All right, take care, have a good evening, and we will see you then. Bye-bye.